All right, so part 3 is going to be answering the question, how does the force of friction and the object's mass affect the acceleration of the object? Looking at the instructions, it looks like we need to click on the acceleration part of the simulation, which is down here. And we want to check all of the boxes that are in that yellow right-hand box. All right, the first one, it says move the friction slider to none. And what changes? Notice that we've covered that track with ice. So it's as if we don't have the force of friction at all. Apply a force to get the mass moving. And the question says, how would you get the object to stop moving? So if I just say 50 newtons of force and it's going, what could I possibly do to stop this box from moving? Okay, things you want to think about the direction of the applied force, think about adding friction to it, how big of a force would you need to add, things like that. Experiment with it and come up with a few different solutions to that problem and write it down in slide 19. In slide 20, it says check the mass so that it's significantly different than before and apply a force to get it moving. I will say that in this one, I think it works best if you have two boxes that are stacked on top of each other. Again, we want to increase the force so that we get movement. There we go. That's pretty good. And our job is to try and stop this stack of boxes from moving. Similar to the question before, but this time, was it easier or more difficult to stop those boxes from moving? Why do you think that is? Write your explanation for slide 20 in that box there. And the last couple deal with a bucket of water. So let me get this set up. We're going to hit reset, check all of these boxes. Instead of a 50 kilogram box, we're going to add a 100 kilogram bucket of water. And we're moving the friction slider to none. So we've got that all set up. Move the friction slider to none, put the bucket on the ice, and apply a force to the bucket until it reaches top speed. So we'll do 100 newtons of force to the right. We can see the speedometer is slowly increasing until we get to maximum speed. The question we're trying to answer, though, is what happens to the water in the bucket as you accelerate to top speed? So if you notice the level in the bucket, the water level, it's not exactly flat anymore. If you're not quite sure, you can add even more force. And what you should see is that water level starts to shift one direction or the other. That's what you want to describe in your answer here. You can also add a description of what happens to the level of that water once you did reach maximum speed, because it does change. In slide 22, while the bucket is still moving, add some friction and decide what happens to the level of water in the bucket when you add friction. So we add some friction here and notice the shift in the water. So that's what you were describing in slide 22. The last couple of slides are just asking you some relationship questions. So how are mass and acceleration related to each other? Think about heavier objects versus lighter objects and how fast they're able to accelerate to maximum speed I think that's just it. How mass is impacting acceleration. Slide 24, how are force and mass related? I said in there, think about two different sized objects trying to reach the same speed. Think about me versus the kid in the shopping cart. Who's going to need more force to get to that maximum speed? And slide 25, how are acceleration and force related? Some big ideas here. I'm going to let you guys read over these ones. They're definitely going to be helpful if you're confused on 23, 24, and 25. But as soon as you get to here, then you're all done.